both A and B will occur. The event that both A and B will occur. Okay, so now do you understand the concept of combination of events? Again, we are picking it from a universal set. Our universal set is the sample space. A is a subset. You know, if you have to write subset, it means that A is a subset of what? The universal set, which is the sample space. B is also what? B is also a subset of the what? Sample space, which is the universal set. So if you are now connecting two subsets together, that is, you are connecting the two of them, you get a compound event. That is, if you say A union B, union goes with the connective or what? Either. Intersection goes with the connective and or what? Both. So if you say A union B, is either that A can occur or B can occur, or both of them will what? Occur at the same time. For A intersection B, A and B will what? Occur. That is the only what? Case. Are you getting what I'm saying? Okay. 5.1 mutually exclusive events. What you say? Mutually exclusive events. Mutually exclusive events. Two events A and B. Two events A and B are said to be mutually exclusive. Two events A and B are said to be mutually exclusive if they cannot occur. Two events A and B are said to be mutually exclusive if they cannot both occur simultaneously. If they cannot both occur simultaneously. If they cannot both occur simultaneously. Full stop. If they cannot both occur simultaneously. Full stop. In set notation, we say that the two sets A and B are disjoint. In set notation, we say that the two sets A and B are what? Disjoint. Are disjoint. Now, where are we going to? Let's consider a Venn diagram. You know, a Venn diagram is a graphical representation in which you can use to what? Represent a collection of well-defined objects, which is a what? Which are a set. Now, this is a Venn diagram containing two subsets. Subset A, and we have set B. Now the universal set, let's still take it to be our sample space, since we are dealing with probability. Now here of A union B, N represents number, which is the cardinality of the set of A union B. The set of A union B. Once you get that set, you count the number of elements there. Now, N of A union B simply means that the intersection of A plus what? The intersection of what? B. If they say that our A is 1, 2, 3, and they say our B is 3, 4, 5, A union B will give us what? 1, 2, 3, 4, 5. You won't repeat that 3 twice, Abi? Are Are you getting what I'm doing? Okay. So n of A union B simply means that this will be n of A plus n of B minus something. What will be that thing? No, it will not be empty set. Look at it. We are adding elements that are in A only. We are adding it to elements that are in B. We are going to subtract A intersection B. You know that here, if you add everything here normally, this should be 1, 2, 3, 3, 4, 5. Abi? If you now say A intersection B, you know that this is like ideally A plus B. This is what it's supposed to give us. If you say A intersection B here will give you what? What is common to A and is also in B? 3. So if you remove 3 from this, this will now remain 1, 2, 3, 4, 5, which is what we have here. Are you getting what I'm doing? So it means that if you are finding n of A union B, you, after adding A and B, you have to subtract the cardinality of the intersection between what? A and B. So this will be minus n of A intersection what? Intersection B. Now, if I divide through by the cardinality of the sample space, which is the universal set, the total number of elements that we have in the universal set. So if we say we are dividing by n of s, this will give us n of A union B over what? N of s is equal to n of A over what? N of s plus n of B over what? N of s minus n of A intersection B over what? N of s. N of A union B divided by n of s is going to give us what? No. It's not 1. Look at it again. The answer is right in front of you. Temi is like, I shall have a close lady. Yeah? No. It's theory. How will this one give you theory? Which number did I give you?
You did not give us the universal set now. How are you supposed to know what again beside it?
You see?
Wait.
Zero yellow. What is it? Yes. Hi, God. You don't want to think. Where is the thing?
We do not know the universal set. How do you expect us to divide it by the universal set?
You are loud, but nothing's coming outside. Look at it. N of A union B. N of S. N of A union B is the event space. N of S is the sample space.
What is contained in the sample space?
Event space over sample space. Probability. It means that n of A union B over n of S is probability of A union B. Did we do this yesterday? Now, n of A over n of S, this is another event space divided by the sample space. This will give us probability of A. N of B over n of S, probability of B. N of A intersection B over n of S, probability of what? A intersection B. Now, where are we going to? We are discussing mutually exclusive events. I've told you that for two events to be mutually exclusive, there is not going to be any intersection. Nothing will be common to each of them. if this is A and this is B, there is no connection between both of them. It means that for a mutually exclusive event, A intersection B will be what? 0. A intersection B will be 0. If it is mutually exclusive, for example, if A is 1, 2, 3, B can be what? 4, 5, 6. A intersection B here is 0. It's an empty set. It is n of A intersection B that will be 0, but A intersection B itself will be an empty set. You know that n represents cardinality. That one is not 0.
So that means that one is not mutually exclusive.
That one is not mutually exclusive. So, but for a mutually exclusive event, the condition is that n of A intersection B will be 0. Yes, there is no element that is common to both of them. So if n of A intersection B is equal to 0 and probability of A intersection B is n of A intersection B divided by n of the sample space, it means that this will be 0 over n of sample space. The probability of A intersection B also will be what? Equal to 0. So it means that for a mutually exclusive event, probability of A union B will give us probability of A plus probability of what? B, and this will be 0. So a question that is telling you that the event is mutually exclusive is this formula you use. If the event is not mutually exclusive, you are going to use this formula. Are you get what I'm doing? Where is formula coming from? Is this not formula in front of you? Oh yeah, right up to that level. In a single true of a fair die, in a single true of a fair die, in a single true of a fair die, what is the probability? What is the probability that an odd number, or a perfect square, what is the probability that an odd number or a perfect square greater than 1 shows up, or a perfect square greater than 1 shows up, or a perfect square greater than 1 shows up. Now, let's consider the question. Here, you are being told to find the probability that you see an odd number or a perfect square greater than 1 shows up. The two sub-events, the first event is event of an odd number. The second event is event of a perfect square greater than 1 shows up. Now, determine the universal set, which is the sample space. Our sample space is the single throw of a fair die. That is what the numbers that can emerge once you throw a die. A die has how many faces? 6 faces. So it means our sample space can be 1, 2, 3, 4, 5, 6. You can't have any number that is lesser than 1 or that is greater than 6, or in between 1, 2, 2, 3, and so on. So now, event A, let's take our odd number to be event A. Odd numbers that are here, we have 1, 3, and 5. This is our event A. Our event B, perfect squares that are greater than 1. So it means that we are not going to pick 1. Greater than 1, 2 is not a perfect square. 3 is not a perfect square. 4 is a perfect square. 5 is not a perfect square. 6 is not a perfect square. So it means that in event B, we have only what? 1 possibility. So here, our n of A is equal to what? The cardinality of set A is what? 3. The cardinality of set B is what? 1. Now you take a look. Is it mutually exclusive? Is there anything that is common to A that is also in B? No. It means that it is not mutually exclusive. That is, n of A intersection B is equal to what? 0. So it means that the formula we are going to use is that probability of A union B, sorry, it is mutually exclusive. I said, is it? And then you see, you're not saying yes, yes, yes. So it is mutually exclusive. Probability of A union B will now give us probability of A plus what? Probability of what? B. Because minus probability of A intersection B, and n of A intersection B already is what? 0. So probability of A union B will give us probability of A. Probability of A is n of A over what? N of S. Event space over what? Sample space. Our n of A here is what? 3. Our n of S is what? 6. So this is what? 1 over 2. So this is 1 over 2 plus probability of B. Our probability of B will give us n of B over what? N of S. Our n of B is what? 1 over 6. So it means that this will give us plus 1 over 6. The LCM here is what? 6. 2 in 6 is what? 3 times 1, 3. 6 in 6, 1 times 1, 1. So this is 4 over 6. The final answer is what? 2 over 3. Probability of A union B will give us what? 2 over 3. Perfection, are you set? Okay. Complementary events. Why is it that? Why is it what? Union. Union represents all.
So it is and we use intersection.
Yes. Yes. Which is a synonym of left.
Stop.
Okay. Now, how many of you remember the complementary law from set theory? Who can state the complementary law? Perfection, can you give it a try? Eh? Complementary law. The complement states that A complement is going to give us universal set. I? Which one is I? I'll be prime. Prime. A prime is also the same thing as complement. Yeah? Which one? Like this? No, it's like this. Yeah, it's the same thing with complements. Are you getting what I'm saying? Now, why will A union A complements give us universal sets? If our universal set is 1, 2, 3, 4, and A is 1, 2, it means that A complement simply means that you remove the elements from set A. You remove what you have in set A from the universal set, what you are left with is your what? Complement. So it means that if you remove 1 and 2 from this universal set, you'll be left with what? 3 and 4. So this 3, 4. So it now means that if you find the union of set A with its complement, you are going to get 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4 is the what? Universal set. Yes, what is not in A is more like negation. Now, in probability, the universal set is the what? Is the sample space. It means that A union A complement will give us what? The sample space. Abi? Abi?
Yes, you say something.
Okay.
They like complement is as negation.
I said it is a synonym of negation, just like negation. Are you set? Okay. So now, if you say that A, or let's say N of A union A complement, it will give us what? N of A plus what? N of A complement minus what? N of A intersection A complement. It's the application of what we just did. Abi? So if we divide through again by the sample, the cardinality of the sample space, it means that probability of A union A complement will give us probability of A plus probability of what? A complement minus probability of what? A intersection A what? Complement. Are you getting what I'm doing? Now, look at this. Probability of A union A complement. If we are to find probability of A union A complement, this will be what? N of A union A complement over N of what? Sample space, which is our universal set. But N of A union A complement is the same thing as the universal set, because A union A complement will give us the what? Universal set. It means that N of A union A complement is the same thing as N of S over N of S, which will give which will give us 1. So it means that probability of A union A complement is what? 1. So instead of writing this, I write what? 1 is equal to probability of A plus probability of what? A complement. For a mutually exclusive event, A intersection A complement will be what? 0. So this will be minus 0. So it means that for a mutually exclusive event, probability of A plus probability of A complement will be equal to what? 1. Probability of success plus probability of what? Failure will be equal to 1. Are you get what I'm doing? You know that if you use 90% to succeed, it means that you have failed 10 what? Percent. 90% plus 10% will give you what? 100%, which is what? 1. Are you getting it? Right up to that level.